In this video, I'd like to walk through one of the Venn diagram problems. This is a really fun problem because it has not just two, but three sets that we're looking at. So let me give you just a minute to read the question, and if you would like to, you can even download this document from Blackboard and use the document to follow along so you don't have to write everything. Has anyone been to California, or now they've opened up in Texas, to enjoy In-N-Out burger? This problem is based off of an In-N-Out location, and let's imagine that In-N-Out burger compiled a survey to 50 of their employees. And when surveyed, 25 of the employees said that they cooked, 19 washed dishes, 31 worked on cash registers. 10 of them said that they did both cooking and registers. 10 of them said that they did both cooking and washing dishes. And only 8 did both and washing dishes. 5 of these valued employees did all 3 jobs. So if I'm going to answer some questions of this data, the first thing I need to do is organize the data. The method we have for organizing this data is called a Venn diagram. Venn comes from the last name of John Venn, who was an American pastor, worked as a pastor in a local church, and on the side did some work with this type of diagram. Here's what a Venn diagram might look like for 3 sets. And let's start organizing this information. Now, let me encourage you with this process that what you want to always do with these Venn diagram problems is start from the inside and work out. So I'm going to start from this innermost, all 3. And by all 3, I mean this yellow part. This yellow segment is going to include the number of participants in the survey, yes, to all 3 jobs. After I've gotten the center, I'll work out. So I'll go next to the exactly 2, this pink, 3 pink segments. So I'm starting inside, working out, and then I'll end with these pieces on the outer part, the 3 things that are left. Now, because this blue highlighter doesn't really do a really good job with being visible once you write on it, I'm going to just leave it outlined in blue and not in blue. So working from the inside out, I'm going to start with the 5, goes right here in the middle, did all 3. 5, let me move this up so you can read each of the things. 5 did all 3 jobs. So that 5, start from the inside and work out. Really easy. I know you may be struggling with this problem, but once you follow this process and practice times, I really think you'll find it to be pretty easy if you do it this way every time. We're going to continue working upward because we're starting from the outside, from the inside and working out. 8 did the cash register and dishes, so that right here, because this pink area is registers and dishes. However, I have to subtract from that the 5 who I've already included. So let me erase this 8 and take the 5 out. So it's actually only 3 additional. Notice if I add them up, 5 plus 3, I get 8. Next we have 10 who cooked and did dishes. So cooked and dishes, that is going to be this segment here. If the total is 10, and I already have 5, I'm going to do the 10 and subtract 5 to get 5. So if I add them, 5 plus 5, I've got 10 all together who cooked and washed dishes. Finally, we've got 10 who cooked and worked registers. So cooking and registers would be a total of 10. We've already got 5 included, so I'll add only 5 additional. Continuing our working from the outside, or from the inside out. So I started at the bottom and I've worked up. So let me just put a pink note here so you can see that that's where those numbers went in. And let me also jot down where I got the 5, 5, and 3. The 3 came from 8 minus this 5, 10 minus 5, and 10 minus 5. Because 5 were already counted. Now we're down to the last 3 segments. 31 operated the cash register. Well, if you count this, you can see that the cash register already has 5 plus 5 plus 3. Got 13 of our cash register operators included. So I'm going to have to do 31 minus 13 to get 18 additional cash register operators. So it looks like 18 register operators didn't do any of food preparation or washing dishes. 19 for washing dishes. Well, of the 19, I've already got 5 and 5 and 3 more. So I'm going to take the 19 and subtract 13 to get that there are only 6 employees who did the washing dishes only. And then finally, 25 cooked. Of the food cookers, we've already got 5, 10, 15 counted. So how many more am I going to put in? I'm going to put in 25 minus 15, or 10. Now, let me show you one other good practice here. Before I start with answering any questions, I want to really be sure that I've organized this information correctly. Notice what I did was I started from the bottom and I worked up. First I did the yellow inside, the pink that fit 2, and then I did the blue, the remaining only ones. Before I go on, what I'm going to do is walk through each of these and ensure that I have that correct. So let's start with this 25 cooked food. I can pull out my calculator and put in 10 plus 5 plus 5 plus 5 is 25 and verify, yes, my 25 is correct. I'm going to just put a slash through it so I know I've got 25. Washing dishes, it looks like we have 5 plus 5 plus 3 plus 6, and yes, the 19 checks out. 31 operated the cash register. I have 18 plus 5 plus 5 plus 3, and sure enough, that checks out to 31. 10 cooked food and operated the registers. Cooked food and registers, that's this 5 and this 5. 5 plus 5 is 10. 10 for cooked food and washed dishes. Where were we? Cooked food and washed dishes, so that's this 5 and this 5, so a total of 10. 5 plus 5 is 10, so that's good. 8 did the cash registers and washed dishes, registers and dishes. 5 and 3 is 8, so that looks good. And last but not least, our 5 is correct. So you see this process I followed. Started from the inside, the intersection of all 3 sets. That's the people that did all 3 jobs, and that was 5. And then I gradually worked up, so working from the inside out. And then after I got to the very top, I did just a good practice to make sure I didn't make an error. So I started at the top and worked down to check all the results. So I think we're ready to go with our questions. You'll probably find these questions pretty easy if the information in the sets has been organized correctly. How many people only cooked food? Do you see that's this 10 right here? How many only operated the register? That's this 18. How many only washed dishes? That's this 6. Which of those numbers come from? Only cooked food would have been cooked food was 25 minus the 5 that did all 3 minus the 5 that did only cooking food and washing dishes minus the other pink 5 that did the cooking food and registers. And you could see that process for values of where the 10, 18, and 6 came from. Moving on to part D, how many washed dishes and operated the cash registers but did not cook food? Washed dishes and did the registers, a total of 8, but didn't cook food. I'm going to have to ignore this 5, so it looks like there's only 3. Washed dishes or operated the cash register. Washed dishes or operated the cash register. So that's wash dishes or register. Notice when I say or. Did you see where I outlined? We can ignore this. All of the, or the cash register or dishes. Notice all of these participants either washed dishes or operated the cash register, but we want to eliminate the cooked food, but didn't cook food. Well, these ones cooked food, so I've got to eliminate those. I'm left with 18, 3, 6. 6 plus 3 is 9. 9 plus 18 is 27. That one was a little trickier. Let me walk through again how we did that. Washed. And, actually, let me go back to D and make sure you notice the difference between these. Washed dishes and operated the register. Dishes and register is only this 8. And then we eliminate the cooks. We have to eliminate this 5. So that left us with only 3. But for part E, it's washed dishes or, means that you can be included if you did either. You don't have to have done both. It's either the wash the dishes or worked the registers was this 18, 5, 5, 3, 5, and 6. But then we had to remove the cooks, the 15 cooks that were included. So we added 18, 3, and 6. How many did at least 2 jobs? I see 5, 5, 5, and 3 that did either 2 or 3 jobs. So 15 plus 3, 18. How many did exactly 2 jobs? Those are the pink 5, 5, and 3. The same 5, 5, and 3 that we had above, but if it was at least 2 jobs, could have included that 5 that did 3 jobs also. But 5 and 5 and 3 is 13. And finally, how many did none of these jobs? Well, let's see how many are included already, because if you recall, we had 50 participants, and we have 10 plus 5 plus 5 plus 5 plus 18 plus 3 plus 6. It looks like there were 52 who answered one way or another. So I'm going to apologize that this worksheet should have started with more than that. Let's say that there were 60. Say that there were 60 employees, because otherwise we have too many. So what that tells us, if we change that to 60 employees and 52 answered sir, that leaves 8 lazy bums who didn't do any of these 3 jobs. Maybe they had a different job at In-N-Out. Like maybe they were cleaning tables or selling merchandise or something other than these 3 jobs. But the way I got the 8 is I added 10, 5, 5, 5, 3, 18, and 6 to get 52. And then I subtracted that from the total number of survey participants to get that there were 8 that did none of the 3 jobs. And that wraps up the problem. I hope you found this helpful. If you do have any questions or would like more help with this type of problem, please don't hesitate to ask. I'd be happy to help you out a little bit more. And by the way, if you're in California or the Las Vegas or Texas area, be sure to stop at In-N-Out. I don't think you'll be disappointed if you like hamburgers or French fries or milkshakes.